Anybody? The formula is x minus h squared plus y minus k squared equals r squared. So the formula for the circle should have been x plus 2 squared plus y minus 4 squared equals 36. I was using this as a barometer to see if you guys needed to do circle questions as part of your review today. I'm going to take that as a big whopping yes. Alright. We only did half of chapter 2 yesterday. We're going to do a few chapter 1 review problems, then we're going to do a few chapter 2 problems, and then I'll cut you loose today. Alright, chapter 1. Let's see. Looks like we started in the teens. First thing I thought here that you really needed to make sure you remembered. What about numbers 15 through 17? Who can tell me the trick to answering those? I'm sorry? Yes. Oh, sorry. This is page 270. Lazarus, what's the... That's right. If the x value repeats, it's not a function. The y does not matter. If the x value repeats, it is not a function. If it does not repeat, then it is. Any questions on that, or is there one somebody'd like to see as an example? 15, there are no repeating x values. It's a function. 17, there is a repeating x value. It is not a function. Questions over that? Alright, next thing I have down is piecewise. Plugging them into piecewise. Let's look at 23. How do I know for part A of for part A of 23, how do I know which part of the function to plug it into? That's right, use the inequality. 13 is greater than 4, so I'm going to plug it into the top one. 0 is less than 4, so I'd plug it into the bottom one for that one. And negative 3 is less than 4, so I plug it into the bottom one again. Other than that, it's just about plugging it into the function and getting out with the y value. Well, let's just actually work through that one. So that'd be 13 minus 4, because 13 is greater than 4. So it'll be square root of 9, which would be 3. 4 minus 0, because 0 is less than 4, so it'd be 4. And 4 minus negative 3 would be 7. Piecewise, it's all about looking at your inequality and figuring out which piece to plug it in for. Questions about that? This is all review, so hopefully nothing is brand spanking new. But any questions? Do some diligent writing, so I will leave this on the board. 21 and 22 aren't even piecewise, so this should be even easier. You just literally plug whatever's in the parentheses in straight for x. So like on part C of 22, that'd be 3 times x minus 1 squared minus 5 times x minus 1 plus 2. And all you'd have to do is a bunch of simplification. Just don't forget to FOIL your binomials. Questions? For which problem? Well, there was a three-parter, so we plugged in 13. The only question was which one to plug it into, the top function or the bottom function. And that's why we had to look at the inequality. 13 was greater than 4, so we plugged it into the top one. 0 was less than 4, so we plugged it into the bottom one, etc. That's all. That's all we're focusing on. Questions? Do I need to leave this up there? Well, I'll leave it up there. The next one we're going to look at, though, is, let's see. We'll look at 33. 33. So if we're writing, I'll copy paste that. You will have your final on Friday. We will not be doing any. Thursday. We will not be doing anything on Friday. I don't really see the point in making our work on a day we have 2 other finals. So we'll take the final Thursday, and you will have kind of a study hall day Friday. Number 33. We are asked to find the domain, range, x-intercepts, y-intercept, intervals of increasing, decreasing, constant, and the missing function values as given at the bottom here. First off, the domain. Who thinks they can help me with the domain? You know what? Scratch that. I'm going to call on volunteers. Justin, what's the domain of number 33? Very good. It goes all the way to the left, all the way to the right with no gaps. Therefore, you can go negative infinity to infinity or all real numbers. What about the range? Holly? Very good. With what around them? Brackets. Domains and ranges is the only thing that you'll have to worry about brackets for in this section. And because they are included, -2 and 2 are actually on this function, they get brackets. The only time you'll really have a domain and range with parentheses is if it's an infinity or an open dot. Like that would get a parentheses. But 271. Part C. Let's see. X-intercepts. Where does this thing cross the x-axis? Nate? Very good, even though my axes didn't show up very well. That is 0. The x-intercept is 0. What about the y-intercepts, Ryan? Again, 0 because it goes to the origin. Very good. Let's see. Interval of increasing. Where is this thing going? Uphill, Lazarus. -2 to what? Very good. -2 to 2. You don't have to worry about the brackets on the intervals of increasing, decreasing, because technically, wherever those intervals stop, then you really can't say. So just parentheses will be fine. Yes, sir. Yes, always. Only thing you'll ever use y values for is the range. Like even intervals of any of those, it'll be x values. In fact, decreasing, I guess this would be increasing. Decreasing, Bridget Passman, what do you think? Well, he said increasing was -2 to 2 from here to here. What about decreasing? Where's it going downhill? Very good, none. And where is it flat? Where is it constant? Zach people? Very, very good. From -infinity to -2, it is constant. And from 2 to infinity, it is constant. No. Intervals, you don't have to worry about it. Because on the endpoints, technically, it could be one or the other. Again, that won't affect you unless it's a domain or range. If it's a domain or range, it'll affect you. Like if these were open dots, these would be parentheses, but not. Here's the thing, it'll be multiple choice, so there won't be a bracket option on those, so I really wouldn't fret about it, about having to memorize it. And last but not least, who can tell me how to find the 2 values at the bottom? What about you, Kevin? Want to take a stab at f of -9? Well, would you agree that -9 is way out here? Would you agree that our function's just tailing off right here? So therefore, can we assume that it's the same y value? There you go. -2. And what about f of 14, Marco? +2. Very good. -2 and +2. Any questions about A through F, any of those parts? How we got something, why we got something, why we wrote something, anything like that. Oh, and these right here? Yeah, they give you the x value and they want the y coordinate. Yeah. What are you saying? Perfect. Any other questions? All right, then we're skipping way ahead. Do I need to leave this on the board? Yes. All right, then the next one we're going to look at probably be 87 or 89, but I have to go look at it. Oh, that's not entirely true. If everyone will flip over to page 273. Page 273. 69 through 81, if you just want to take a look at those in your books. Those are all parent function questions. 69 through 72 is x squared. 73 through 75 is square root of x and the absolute value, then x cubed. And they're all a whole bunch of transformations of parent functions. If you have one like that on a test, it'll be, here's a function, which one is the graph? Or here's the graph, which one is the function? So rather than do specific examples, here's what you need to know about all of those. All you really need to know is what the parent function looks like. You need to know what the parent function looks like, and you need to know what everything does. X squared is a parabola. Square root of x is a half sideways parabola. Absolute value is a v, and x cubed is one of those. After that, all you need to know is what all this stuff does. What does it do when you add a number outside of the parentheses, way out here by itself? It's a vertical shift. When you add or subtract a number outside the parentheses, like numbers 69, 76, 77, those are vertical shifts. When you add a number inside the parentheses or inside the radical or absolute value, what does it do then, Melissa? That's right, the left or right shift. So x plus 2 would go where, Jalen? X plus 2 in the absolute value would shift you where? Right, left 2. Remember, when it's inside, you take the opposite. That would be like 71 would be left 1. 74 would be, well, that's actually flipped backwards, but that would be positive 3, etc. Questions about any of those? Just the parent functions, what they look like? Yeah. If you graph x squared or square root of x or just the raw function without anything being done to it, that was what like that shape will look like. This is a parabola. This one, there should be some of these all over the board. Like here's x cubed, oh, the wall. There's an x squared. There's an x squared. That x cubed over there, cube root. These are what we did earlier in the year. They're all the same shape. Like all of 69 through 72 will all be parabolas. The only thing that'll change are the shifts, and maybe they might be a little narrower or broader depending on the number in the front. But here's another thing. You can use your calculators tomorrow. So let's say they give you a function and they say which one is the graph of this function. Now the only thing you'll really have to pay attention to is the scale they're using. But you can graph it on your calculator and just see which one looks the most accurate. So when in doubt, use your calculator. Thursday. Questions about those? Other questions? I didn't even put any problems like this on there because I didn't really know which one to choose without choosing one of everything. So, but since you can use your calculator, those really shouldn't be that bad. Although I guess that's not true if you use it. Oh yeah, there you go. Other questions? Any questions? All right. Let's see. Domain. Numbers 85 through 90. Find the domain. Who can tell me the trick there? What about you, Nate? What's the trick? Mr. Pacito? Mr. Harris? There were two things. One, you can't have a 0 in the denominator, so that's good. Why the heck did I put that? So, like for number 86, that'd be all real numbers except x cannot be 7, for instance. It's wherever the denominator equals 0, or it's wherever what's under the radical is going to be negative. So for 89, you'd have to take x minus 2 and set it greater than or equal to 0 and solve that. So that'd be x is greater than or equal to 2, and x cannot be 5. And then it'd be all real numbers other than that. What? Yeah, it's recording right now. Well, good question. Is there a radical or denominator? Nope, all real numbers. If you don't have either of those, it's going to be all real numbers. Good question. Other questions? Number 9. Tell you what, let's do one like 90, because I just might be assigning that one later. So let's do one like 90. How about if you have a function like, let's see, f of x is the absolute square root of x minus 3 minus the square root of x plus 2. You have to do them separately. So this would be x minus 3 is greater than or equal to 0, and x plus 2 is greater than or equal to 0, because they just can't be negative. So that would be x is greater than or equal to 3, x is greater than or equal to negative 2. Which one encompasses the other? Very good. That would be your domain. Because if you're true about this one, then it's also true about this one. But negative 1 appeases the right one, but not the left one. So if you have a multiple radical, then you have to do that. So, yep. Oh, appreciate it. Question about that. You see a radical, you ask for the domain, to set what's underneath it is greater than or equal to 0. Why don't you use those three? Well, because what's the number greater than or equal to 3? 4, right? 4 is both greater than 3 and greater than negative 2. Let's say you chose a number like negative 1. That satisfies this one, but not this one. And has to satisfy both. That's why. That's why. Questions? Is it getting a little chilly in here? All right, next example. Only 2 more in this chapter. Let's see. Number 90, well, it didn't show up very well on mine, but number 95 is what we're going to do. Well, whatever. This isn't going to be very pretty. We're going to do number 95 together. We have to find f of g, g of f, and then f of g of 3. So f of g would be what? The square root of x plus 1. You plug this in for the x of f of x. Technically it's of x. And then g of f would be what? Who can tell me what g of f would be? Radical x plus 1. Very good. You plug this entire function in for just the x over here. Very good. F of g of 3, what's the only thing we have to do? That's right. Go back up to the f of g function and plug in 3 for it. So that would be square root of 3 plus 1 or 2. Or negative 2. Questions about compositions. There will be at least one composition problem on your midterm. Well, did you understand the first part of this part? Yeah. So all we did was plug 3 into that. Square root of 3 plus 1. What? Well, it would still be the same thing. 3 plus 1, square root. Yeah. Other questions? Square root of a number. Yeah. I'm guessing. Well, I don't know. Actually, that would be a good test question. Just combine multiple things. F of g of 3. Good test questions on things like midterms and reviews, I'll just tell you now, are the kinds of questions that encompass several different topics. Because there's no way in 20 questions I can get to everything we've learned. So like this would be a good test question because that incorporates plugging numbers into functions, which we've practiced, and it incorporates compositions. So that's an example of a good test question. That's how I select them when I make it. Things that cover several topics. Questions? Alright, the only other thing I wanted to look at from this chapter, well, actually that's not true, now that we have circles as well, was finding inverses. Number 103, we have to find the inverse and then check and make sure that it's the inverse, which you only had to do to cover your bases. But who remembers how to find an inverse of a function? Mark it. Very good. Very good. So that'd be x minus 1 equals 8y cubed. Divide by 8, that's right. And then what? Cube root. So that would be f inverse of x. Now who remembers how to check this? How can you check these to see if you're right? Not necessarily a number, but well, I don't know, it'd be interesting. You compose them, f of f inverse. And what should you get if they're inverses of each other? You get x. Remember? When you compose two functions and you get down to nothing but exactly x, then they're perfect inverses of each other. So let's see. We're going to take f of f inverse, so we're going to plug this into that. So it's going to be 8 cube root of x minus 1. Oh, the whole thing was under the cube root, wasn't it? Cube root of x minus 1 over 8 cubed plus 1. Sorry, I know it's kind of messy. In fact, I'll rewrite it. We're plugging f inverse into f. So that'd be the cube root x minus 1 over 8 cubed plus 1. So the cube and the cube root are going to cancel, leaving you with 8 times x minus 1 over 8 plus 1. The 8's are going to cancel. You're going to be left with x minus 1, x plus, or plus 1, and what's going to happen? X minus 1 plus 1 cancel also, and you're left with x. So yes, they are indeed inverses. Again, you probably will not be required to do that, but you may be asked to, it may just give you two functions and say, are they inverses? And that's the quickest way to find out. Just compose them. And you should get x. Questions on that problem about what we were asked to do and how we did it? Anybody else ready for spring break? Yeah. Man, I'm exhausted. It's only Tuesday. I feel bad for you guys. You guys have to take tests. No. I'm not biting on that. No. Okay, the only other thing I really want to make sure we know, technically, we did do graphing lines and stuff. That's really more of a geometry thing. I might put something like that on your final, but I'm not going to bother with the midterm right now. However, you really dropped the ball on these thank you, those, yes, on the circle things. So let's quickly make sure that we actually, this is distance formula, which again I'm not going to worry about now. Midpoint formula, which I'm not really going to worry about now. Those aren't really calculus topics. This is the one we did in the DOM. So rather than add it to your review, let's just do 116. What would the form? Actually, I'll make up my own problem. If this was your center, and well, that doesn't make sense. I have a negative radius, and your radius was 5. Sam, what would my equation be for my circle? That's right. Yes. Muy bien. Very good. And then again, it also might just give you this and say, what's the center and radius? Which case, we'll just work backwards. -3, 7, square root of this number is your radius. I'm not saying there will not be a circle question on your midterm. There might be. But there won't be another one on your review today. Questions? Alright, Chapter 2. I believe it's page, I have no idea what page it was. Chapter 2 review. I'll be able to tell you in just a second. Yes, we did. Yes, we did. So today we will start in 50 at 2.5. This is page 383. 383. Now, in light of the fact that you can now use a calculator for most of these graph things, which is what we did yesterday, I'm going to be looking for questions to see if you can also still do it by hand, which is why numbers 49 and 50 will be very enticing for me, because all you have to do is list your P over Q's, which is an easy question, but you can't use the calculator for it. So, number 49, list all the possible rational zeros. Who can tell me how to do that? Sam. Very good. So therefore your P over Q's. Very good. And if I'm going to put the if in blue, if this had been like 2 and 3, then that'd be 1 over 1, 5, 1 half, 1/3, 5 halves, 5/3. All possible combinations of our P values over our... No, because they're the Q's, not the P's. Yeah, Q's are the denominators. Good question. Questions on that problem? All right. Next thing I thought we should look at, I'm not really so concerned about Descartes, but let's see. What about number like 59? Essentially, all of this says, basically all of this breaks down to graph it, although I guess it doesn't ask you to graph it. It asks you for all the rational roots, which is P over Q. You don't have to do Descartes, although it's quite simple, just looking for sign changes. Use synthetic division to test the possible P over Q's, and use the quotient to find the remaining. So like for 59, now what's a huge hint for 59? What kind of function is that? It is an even function, which means what? They're all, yeah, it's the perfect way to word it. They're all mirrored. It means it's symmetrical, which means if you find one root, like -1, then that means +1 also has to be 1. So our P over Q list, as we just looked at a second ago, should be plus or minus 1, 2, 1/4, and 2/4, which is 1 half. There's our P over Q list. We need to find 2 of them, but luckily, since it's an even function, we find 1, we've actually found 2. Now again, you can do this on your calculator now. I'll do it both ways. On your calculator, if you do 4x to the 4th plus 7x squared minus 2 graph, we need to find those 2 roots. At least the 2 that are showing up there. So I'm looking for my zeros. I hit 2. Don't really scroll down. Let me just actually click it. My zeros. Left bound. I guess we'll look for this one first. So go to the left of it, hit enter. Go to the right of it, hit enter, skip. What's that say? -1/2? You could do the same thing, or just use the fact that it's an even function to know that if -1/2 works, then +1/2 works. Now this will also be an excellent question for tomorrow, because it looks like that only crossed the axis twice. But how many roots should we have? So you're still going to need to know how to take these out to find your imaginary roots. So that'll be -1/2. How do we take it out? Synthetic division. Sarah, how am I going to set up the synthetic division? We're doing this one first. What numbers go here? Nope. Your coefficients. Pay attention. 4, 0, 7, 0. Why the zeros? There's no x cubed function and there's no x, so we have to plug in zeros for those. So drop the 4, multiply, add, multiply, add, multiply, add, multiply, and if you did it right, you should get 0. Now what do we have to do? You have to take out the other one. Very good. Remember, take the other one out of your depressed polynomial, not the original. That's not going to do you any good. So, drop the 4, multiply, add, multiply, add, multiply. Yay! Making your depressed polynomial 4x squared plus 8. Then how do we find the last two? Quadratic formula. Negative b, which is just 0. Of course, I guess when you don't have a b value, you could just solve it. But b squared minus 4ac all over 2a. So that's plus or minus, what's 16 times? 144. Is that 12i? I believe 4 times 4 times 8 is 144. Negative 144 is 12i when you take the square root. So that'd be plus or minus 3/2 I. Yes, sir. Did I mess up? Oh, no. Dang. What's the square root of 128? Oh, it's not. You're right. Which, let's see, would that be 64 and 2? I can write. 64 and 2 is what that would be, right? So that'd be negative 8i radical 2. Or not negative, but 8i radical 2. Thank you for the correction. So how would that reduce? Very good. The 8s would cancel. So these are your other two roots, and your first two were 1/2 and negative 1/2. This would be an excellent test question because you would still have to do what we learned, and you could still use the calculator for it. So it like covers many bases. Not that you have to use the calculator. You don't. But the only reason the calculator is helpful is because now you know you don't have to bother looking for 1 or 2 or 1/4 because you can find the first two. Of course, on the multiple choice test, it'll probably give you the ones you need anyway. So you can use those context clues. Questions? There's really only 3 other things I wanted to look at. I want to make sure we get this covered first. Are there questions about what you're going to have to do there today? It didn't ask you to graph, just asked you to basically find the roots. All right. 72 through 78, I guess for us, 71 through 79. I wanted to look at this entire section. Now, please make a note somewhere in your notes so that I don't have to remember to say it later. You do not have to graph these today. You do not have to graph these today. But what you do have to do is find the asymptotes, the vertical, the horizontal, and the slant asymptotes. Who remembers the trick to finding the vertical asymptotes? Yeah, it's wherever the denominator equals 0. So this one's going to have a vertical of 9. This one's going to have a vertical of negative 1. This one's going to have a vertical of none. There is no vertical asymptote. 73, however, let's see. What is this? X minus 4x plus 1 on the top. What? Okay. And on the bottom, what is it? X minus 3x plus 2? I only needed to do that to see if something canceled. Remember, if something cancels, you will no longer have a vertical asymptote for it. But nothing's going to cancel. So where am I going to have vertical asymptotes on this thing? 3 and negative 2. It's just where the denominator equals 0. Oh, touche. I was thinking it was x minus 9. Plus or minus 3. You're correct. And I'm incorrect. So the verticals, all about where the bottom equals 0. What about the horizontals? Right. The horizontal asymptote chart, which is where the highest power was. It'll either be top, bottom, or both. What is it on 71? If it's in the bottom, who remembers what it is? That's right. It's the horizontal asymptote at 0. Every time. If it's in the bottom, it's 0. If it's in the top, like number 75 and 77, no. If it's in the top only, it's just none. So, wait. No. Touche. The chart? I'll write an abridged version of it. The horizontal asymptote chart. Highest power, horizontal asymptote. Only 3 possibilities were the top, the bottom, and both. If it was on the top, you will have no horizontal asymptote. If it was on the bottom, it's going to be the line x equals 0, or just 0. And if it's both, it is the quotient of the leading coefficients. That's essentially the entire horizontal asymptote chart. Highest power. If it's in the top, you have none. If it's in the bottom, it's 0. And if it's both, it's the quotient of the leading coefficient. So, yeah, and just the leading coefficient. So, Latifah, what would the horizontal asymptote be on 73? Very good. Because the highest powers are x squared. What does that reduce to? 1 over 1. So just 1. Only thing that matters is the leading coefficient on those. It's Bridget. Because nothing can make x squared plus 1 equal to 0 without it being imaginary. Now, it also asks for slant asymptotes. Slant will only exist if the top is exactly 1 power higher than the bottom. That is the only time you're going to have a slant. Does this one have a top of 1 power higher? No. So this one will have none. What about number 73? Is there a slant? Nope. Another thing to remember is if you have a horizontal, you're not going to have a slant. So the only time you could possibly have a horizontal or a slant is when there's no horizontal, which is what happened here. Now, if it is 1 power higher, then you can just divide. Now this one you could do synthetic division with a -1. This one you have to do long division. We practiced division yesterday, so we won't really go into that. But if it's 1 power higher, then you just divide using long division or synthetic, either one. And whatever you get, you can just chuck the remainder, is your slant asymptote. It'll be like x plus 2, x minus 3, x, something like that. Negative x. Questions? Then we're going to move on. You are going to have 4 of those today. You'll have 7. I mean, don't do them yet. I know if I tell you what numbers, some people are going to be like, ooh, I can get ahead. Please don't. We have some more to do. But you do not have to graph these. You just have to list the 3 asymptotes for each one. And 2 things left. One was, oh, these. They're both in this section. Zoom. Solving inequalities. These are the exact same as just if these were equal 0, finding the roots. Who remembers the only difference about when you find the roots on 85 and 87? Well, I'm going to come back to what you said. What he's saying, once you find your zeros, so that one you could factor, you can do quadratic, this you can do P over Q, you can graph it and trace it, either way. When you find the zeros, you have to subtract it over first, of course, then you have to put them on a number line and check your intervals, because it is no longer equals, it's an inequality, and you have to see if it satisfies the inequality. We'll do one of these together. And then 89, if it has a denominator, remember that's another place. So what 3 values do we have to check here? Let's look at that one real quick, since it's kind of the quickest. Well, actually, that's the easiest one, I guess. Let's do 87. Let's do 87 together. How many numbers will be on our number line when we're done? 3, the degree, unless there's a double root. So, X cubed plus 2x squared minus 3x is greater than 0. You can use any technique you want. You can do P over Q. You can graph. You can factor. I think factoring will save us some time here. What factors out of this? Well, just x first. Then you have x squared plus 2x minus 3. Now, what were you saying, Marco? Plus 3 minus 1. Now, this one happened to factor. Yay, they won't always. So the three numbers we need to check on the number line are what? Very good. Very, very good. So, here we go. What's a number less than negative 3? Negative 4. Let's just use this function right here. Negative 4 cubed, negative 64, plus 32, minus or plus 12. So that'll be a positive number. Is a positive number greater than 0? Yes. Shazam! Check mark. Oh, was it negative? Oh, oops a lot. Sorry. So it would not be greater than 0. What's the number between negative 3 and 0 we can check? Negative 1. Always use 1 if you can. So it'd be negative 1 plus 2 plus 3. I think I'm right this time. That'll be a positive number, which is greater than 0. Yay! Number between 0 and 1? 1/2. Sounds good to me. So that'll be 1/8. 1/4 times 2 is 1/2. Minus 3/2. Is 1/8 plus 1/2 minus 3/2 positive or negative? It'll be negative. Is a negative greater than 0? No. And then you try a number greater than 1. I'm getting a little exhausted. Number greater than 1. How about 2? You try 2. That'll be 8. I realize the hypocrisy. Minus 6. That is positive, so yay. So that would be your answer, that number line. Well, I have to say all this stuff nice and loud. It's not the math. Vote. It probably sounds so pathetic, doesn't it? Yes, it does. Okay, I accept. Questions? If it's pre-factored for you, that's even better. You can just pull them straight out. Here is your assignment. That's right. Yay! Work time. All right. Page 270. Okay. Here's the other. All right. 16. Just kidding. My number lock's not on. 16, 24. There you go. Oh, freaking idiot. What, how about review part 2? Review part 2. And then tomorrow we'll do a pretest. Then Thursday you'll all ace your midterm, and there will be much rejoicing. You'll be fine. Long, long time ago.